Today we're going to be calculating the velocity and time of various objects rolling down our ramp. Our supplies today are going to be a foot-long ruler, a measuring tape, a calc, a golf ball which represents a sphere, a roll of tape which represents a hoop, a PVC pipe which represents a rod, and a toilet paper roll which represents a hollow cylinder.
Now it's time to measure the height of our ramp. We've constructed our ramp with a long piece of wood and a wooden ladder. As you can see, our height is 3 feet, which comes out to about 91 centimeters. Now, it is time for our hypothesis. We believe the sphere will move the fastest, followed by the hoop, then the cylinder, and finally, the rod will move the slowest down the ramp.
First object we're going to roll down our ramp is the golf ball, or the sphere. Our next object is the roll of tape, or the hoop. Our third item we're going to roll is the toilet paper roll, or the cylinder. Our last item is the PVC pipe, which is the rod.
This is our sphere calculation. First, we start off with UG equals K plus K rod, because we are rolling something down a hill. Then, we must substitute our I and W formulas in, which include 2 over 5 mr squared and v squared over r squared. After canceling out our r's and m's, we end up with GH equals 1/2 v squared plus 1/5 v squared. This then turns into v equals the square root of 10 over 7 GH. Next is our cylinder formula. We do the same process as last time, but this time use a different I formula. It is 1/2 mr squared. We then cancel out our r's and we cancel out our m's, and we get GH equals 1/2 v squared plus 1/4 v squared. This ends up giving us GH equals 3/4 v squared, and finally, v equals the square root of 4 over 3 GH. Next is the rod formula. Once again, the same as last time, but we are now changing our I formula. This is now 1/3 mr squared. This ends up giving us GH equals 1/2 v squared plus 1/6 v squared. Finally giving us GH equals 4 over 6 v squared, or v equals the square root of 6 over 4 GH. And finally, our hoop formula. This is the exact same as last time, but now our I formula is just mr squared. This ends up giving us GH equals 1/2 v squared plus 1/2 v squared, or GH equals v squared. Finally, giving us v equals the square root of GH. We then must plug in our g of 9.8 and our height of 0.91 meters. After that, we have concluded that our sphere's velocity will be 3.57 meters per second, our cylinder's velocity will be 3.45 meters per second, our rod's velocity will be 3.66 meters per second, and our hoop's velocity will be v equals 2.99 meters per second.
For the golf ball, we release it at 0.57 seconds, and it hits the bottom of the ramp at 1.93 seconds. In this one, the toilet paper roll starts rolling at 1.05 seconds and hits the bottom at 2.98 seconds. For the PVC pipe, we released it at 0.67 seconds, and it hit the bottom of the ramp at 2.18 seconds. As you can see, we released the hoop at 0.51 seconds, and it hits the bottom at 2.01 seconds.
After subtracting the finishing time by the starting time, we have concluded that our sphere took 1.36 seconds to roll down the ramp. Our cylinder took 1.93, our rod took 1.51 seconds, and finally, our hoop took 1.5. In conclusion, our hypothesis went 2 for 4. We believed the sphere would move the fastest, followed by the hoop, then the cylinder, and then the rod. But in reality, it was actually the sphere, followed by the hoop, and then followed by the rod, and finishing in last was the cylinder.
All right, we're going to be doing 3 of the 10 multiple choice questions that we made for a little practice. The first one is, what determines how fast the object rolls down the ramp? Is it A, the moment of inertia, B, the wind, C, its mass, or D, its gravity? And the answer is going to be A, the moment of inertia, because each shape depends on the amount of mass, the way the mass is distributed. For number 2, which of the 4 objects had the highest moment of inertia? Was it A, the golf ball, B, the toilet paper roll, C, the PVC pipe, or D, the roll of tape? The answer to this one is going to be D, the roll of tape. Because the roll of tape is a hoop, its mass is distributed on the ends and furthest from its axis of rotation, giving it the highest moment of inertia. All right, last one. Number 3, why was the roll of tape slower than the golf ball? Was it A, its radius is greater than the golf ball's, B, it has a higher moment of inertia, C, it's taller than the golf ball, or D, none of the above? The answer to this one is going to be B.
Rotation.